Welcome to episode number 5 of our Design Patterns in Java series. In the last episode, we built complex objects using the builder pattern. But what if creating an object is expensive due to memory cost, database calls, or computation, and you want to create copies efficiently? Enter the prototype pattern. It lets you clone existing objects instead of creating new ones from scratch, which is especially useful in scenarios where instantiating a class is costly or complex. So what is it? The prototype pattern is a creational pattern that lets you create new objects by copying existing ones, known as prototypes. This is done using cloning, typically via a clone method or copy constructor. Java provides a built-in clonable interface, but it's often better to define your own clone method. What are the use cases for this? Well, avoiding repeated expensive object creation, when a system should be independent of how its classes are created, in game development, copying character templates or whatever you want to do with that, UI elements, templates, or default configurations. Now, let's go with a real-world analogy. Imagine you are at a coffee shop and the barista doesn't make every new drink from scratch. They start with a base recipe and adjust from there. That's cloning in action. We're using a template and customizing it. So let's go through our code. And I need to be small for that again, so you guys can actually read the code. Bam! Let's go through it. Let's say we have a document class used for generating templates, rather than constructing a new document every time. We'll clone an existing one. We have to define the prototype interface, and to do that, we have to go to this file. Now, what I've created is a prototype with a generic, like in my TypeScript course. Java also has generics, the wonderful world of generics. And we can put in anything here. We can put in strings, integers, custom objects, whatever. And the clone function returns that. So what it does here is, let's say string, and then this will be squaring, and I almost ruined the file. So yeah, that's not the case, but like if it's string, it's string. If it's Y like this, it's Y like that. Or T, or whatever we put in first. All right, let me restore the file because I kind of destroyed it with my example. But let's say we put in a string here, then this automatically becomes a string. I'm just saying this for new programmers. If it's an integer, it's an integer. It's a custom class, it's a custom class. All right, so that's how generics work, very simply explained. So we have made a prototype and it has a clone function which returns type T, and type T is what we pass in there. Right? All right. So implement a concrete prototype. Let's do it. We have a document here. We have a clone. We have a set title, set author, and a toString. And what the clone does is it returns a new document, title, content, and author included. So that's what it does. Now, let's see it in use. So we have our main class, and then we have our document, the original document. So I've called it original. It has template. This is a base template, and author is the system. Now we can say document user doc is original.clone. So we clone the original document with everything in it. And then we just set a new title and set a new author. So what we have done is we have not taken the object reference and then changed it, because then it will be mutable, right? So let's say if we do this. So what you see here is it creates new documents every time, but with everything new with the setter, right? So what we have done here is we have created a new document with all of the data that is provided in here, right? And then we just change it with the setter. Now, what we haven't done is we haven't passed the reference. So we don't give the reference like original, because if we would do the same thing with original, then we have original here, and then we would go and say system out, print line original, and then we say original, this is a like this, and then we can do it like this. Just change this to original. Let's comment on this piece of code. So what happens now is that we have just changed the reference. We just changed stuff on original. So that doesn't work. And this is very beginner friendly explanation. So if you're more advanced, then you already know that this is just, not working. We don't have a new object here. We're just changing stuff on the old object, which just changes it. So like this, it changes original. That is not what we want. We don't want to change the original. We just want to make a copy of the original and then just change stuff on the copy. And that is exactly what we do here. We take the original document, which is a template, and then we take the template, we clone it, and what it does is it returns a new document with all of the contents from this document, and then we change it. So that's what we do. We create a new object, and then we change everything so the original reference doesn't get destroyed. That's basically what it is with the prototype design pattern. You prototype it, you return it with a new one, and then you can change it. So yeah. What actually are the benefits of the prototype pattern? It avoids repetitive object creation logic because you can just create one with the clone and then just set some other fields and you're all fine and good to go. It's great for performance sensitive applications. It reduces the constructor complexity because you don't have to, do the constructor all again, because you can just clone it, set some fields in, and you're done. It reduces the constructor complexity with that, like I said before, and it enables runtime object configuration and variation. There are some challenges and gotchas. There's deep versus shallow cloning. Java's default clone does a shallow copy. If your object contains references to other objects, you'll need to clone them manually. Cloning can become complex if objects contain circular references or require special handling. Java's clonable interface is flawed. No clone interface method in the interface, and it has broken contracts. There are some other alternatives to cloning. You can use copy constructors for better control. You can use serialization, a deep copy via streams. It's slower but more flexible. And you can use the builder pattern if construction is modular and step-based. So some best practices for this are: prefer your own clone method over Java's clonable. Keep clone logic localized inside the object. Document whether the clone is shallow or deep, so you can make a shallow clone or a deep clone. A deep clone also, if you have an array of stuff, then it puts everything in the next object, not just an empty array, but also the stuff in the array. And if you have references, it takes all those references and puts them in the new one as well. A shallow clone doesn't do that. So it just does like the first couple of entries, just variables, stuff like that. So be sure to make a distinction between a shallow or a deep clone and combine it with the factory or builder pattern if needed for flexibility. Now, in this episode, we explore the prototype pattern, a practical tool when you need to clone objects instead of constructing them from scratch. It shines in situations with expensive setup logic, and it offers flexibility for runtime configuration. In the next episode, we'll move into the adapter pattern, a structural pattern used to bridge between incompatible interfaces. If you found this useful, be sure to subscribe, like, and comment, and be sure to share it with your fellow programmers. Have a good day and happy programming.